Most people assume prehistoric humans constantly had children with their own relatives because there were so few people alive. It sounds logical. Small tribes, isolated families, nowhere else to go. But DNA recovered from ancient skeletons tells a completely different story. Long before governments, written laws, or even agriculture, humans were already finding remarkable ways to avoid one of evolution's greatest dangers. The real story is far stranger than most people imagine. To understand why, you first have to imagine the world our ancestors lived in. Prehistoric humans didn't spend their entire lives trapped inside a single cave with the same handful of people. They lived as hunter-gatherers, moving across enormous landscapes in search of food, water, and seasonal resources. Their groups were small, usually between 20 and 50 individuals, but they weren't isolated. They regularly met neighboring bands, exchanged gifts, shared knowledge, celebrated together, and sometimes welcomed new members into their communities.
This constant movement created something surprisingly effective. Even without understanding genetics, prehistoric humans reduced the chances of close relatives having children together. Scientists have found evidence of this in places that are tens of thousands of years old. One of the most remarkable discoveries came from ancient DNA studies in Eurasia. Researchers expected to find widespread inbreeding among Ice Age hunter-gatherers. Instead, many individuals came from parents who were only distantly related. The genetic diversity was far greater than anyone expected for such small populations. One extraordinary discovery came from a burial site in Siberia, dating back roughly 34,000 years. DNA analysis revealed that the young boy buried there had parents who were not close relatives. In fact, his genetic profile suggested his community exchanged partners with neighboring groups over long distances. Even during the harsh conditions of the Ice Age, people were maintaining social networks that stretched far beyond a single camp.
Archaeology supports the same idea. Stone tools, shells, pigments, and other materials have been discovered hundreds of kilometers from where they originated. These weren't random objects. They were signs of contact between different communities. Wherever people exchanged tools, stories, and ideas, they also had opportunities to form new families. Of course, this doesn't mean inbreeding never happened. During times of extreme isolation, natural disasters, or when populations became dangerously small, some communities likely had little choice. Genetic studies of a few prehistoric individuals do show close relative unions, but these cases are rare rather than typical. They stand out precisely because they were unusual.
This makes evolutionary sense. Children born to closely related parents have a higher chance of inheriting harmful genetic mutations. Groups that regularly avoided close relative mating would have produced healthier offspring, giving them a better chance of surviving, hunting, and raising the next generation. Over thousands of generations, communities that encouraged partnerships outside the immediate family simply had a greater chance of lasting. What's fascinating is that prehistoric humans didn't need to understand DNA to recognize the pattern. They only had to observe the world around them. If certain family lines repeatedly produced weaker children, while others thrived after bringing in newcomers, those experiences could gradually become customs, traditions, and social rules passed from one generation to the next. Today, genetic research continues to uncover just how connected our ancestors really were. Instead of isolated caves filled with close relatives, the evidence points to a vast network of traveling bands that met, traded, celebrated, and formed relationships across surprisingly large distances. For thousands of years, humans survived not by staying closed off to the world, but by reaching beyond the people they already knew. Long before anyone understood chromosomes or genes, our ancestors were already practicing one of evolution's oldest lessons. A species grows stronger when its connections reach farther than its own family.